Hello, eighth graders. This is Mr. Brewer, obviously. Hope you're doing well on this day before spring break. So hopefully when you're watching this, if not, maybe you're going back at another time and watching this video to maybe review this quiz. If you're trying to improve your score on the quiz. So um, what I'm going to do in this video is just walk through specifically the lessons that we've seen leading up to this lesson 6.04, which is the culmination of the Pythagorean theorem. So we're going to look at kind of all the ideas we've seen, do some basic questions. We're going to look at all the questions you're going to see in the quiz. So this video should help you if you're struggling with that concept, review and prepare yourself um, for um, for what you can expect to see on the actual 6.04 quiz. Okay, so without further ado, let's check out what essentially you're going to see in question one. So it says find the length of the missing side. Okay, so let's do a quick review. So if we're considering the Pythagorean theorem says a squared plus b squared equals c squared. Now, that might not make a whole lot of sense to you, so let's break that down. So the Pythagorean theorem is an idea that was put out by Pythagoras. We talked about that in class. Crazy old dude from thousands of years ago, and he found that in particularly a right triangle. So this only applies to right triangles. That certain properties applied. So what he found was if we took one of the legs, which we can say A for a leg, and a leg is next to the right angle. So we know that this angle right here is 90 degrees. That's a right angle. This would be A, or the other leg. I'm going to call this B. Um, those are interchangeable. You could call one A and one B. Doesn't really matter. What is significant is the opposite side, which is the hypotenuse. So the opposite side from the right angle is the hypotenuse, and we call that C. Okay, and in this case, that's 15, right? So we have 9, 15, and question mark, right? We don't know what that A side is. Well, thankfully, we have a formula which we can plug in the numbers and find out what that missing side is. So let's do that in this question. So I'm going to substitute in all the lengths that I know. So A, again, this is the missing piece, so I'm going to leave that as A squared. I'm going to plug in my value for B, and that's 9. So we're going to have 9 squared equals my value for C, which is the hypotenuse. Again, the hypotenuse is it's always the longest side of a right triangle. It is also across from the 90-degree angle. So that's 15. So 15 squared. Okay, so now I can actually start to do some math here. Sorry, that 9 looks a bit like an A. Let's lengthen that a little bit. So I'm going to solve, I'm going to find the square of 9 and 15 and simply take those as now if do a refresher. So when I say 9 squared, what we really mean is that's that number times itself. So that's 9 times 9. When we say 15 squared, we really mean that's 15 times 15. Okay, so just so you know where we're going. This is calculator work if you would like. If you know the math facts, great. If you don't, it's okay. So a squared, that again, that remains the same. I'm just gonna keep drawing that piece down. We don't know what that is. That's gonna be continual as we just go down in our equation. So let's go to our 9 squared. 9 squared is 81. Okay, equals 15 squared is 225. So now at this point we have a variable expression, and I'm going to solve for the variable. Excuse me. So what I want to do is essentially isolate the variable, kind of like what we've done in semester one with any variable equation. So I'm going to isolate that variable. I'm going to move the 81 over with the 225. I'm going to do that through inverse operations. So I'm going to subtract 81 from this side, subtract 81 from this side. And let's see what I come up with. So my simplified, obviously this is 0 now, so that's gone. That's great. I'm going to bring down my a squared equals And 225 minus 81, that should give me 144. Okay, so at this point in time, I know that a squared is 144. Um, that that doesn't mean that a equals 144. Okay, obviously, if you look at just the number sense of this, if this side is 15, if this side is 9, there's no way this side could be 144. That just doesn't make sense. So how do I do with this? Well, now I need to actually take the square root. So because I want to find a, not a squared. So what I would do is take this final step. I'm going to rewrite this again. A squared equals 144. I'm going to take the square root of each of those numbers. So I'm going to put a square root symbol over top of those, or the radical symbol over top of those. And what that's going to do is that turns a squared into a. I'm going to kind of go up here. And then I'm going to take the square root of 144. Well, the square root of 144 is 12. And so now I have my official answer for this. I know that a is equal to 12. And now, again, logically, if I look at that, okay, yeah, that makes a lot more sense, right? If this side is 15, if this side is 9, then it does make sense for this side to be 12 centimeters. In this case, that fits with the logic and the kind of just visually looking at this question. Okay, so that is question number 1. So you could have any of the sides, right? In this case, we have a missing length of the A side. The B side, if we did that, we simply would have the same sort of equation, and same thing with missing the hypotenuse. That would actually be slightly easier, to be told. Okay, so that's question number 1. We'll jump to question number 2 now. So again, all these questions will be very similar. So find the length of a hypotenuse in a right triangle with the following two side lengths. So again, here's that situation that I kind of just described. We're now given A and B, and we're supposed to find C. Now this question did not give me actually a picture, so what I did is I actually just drew a quick triangle. It's not perfectly accurate to these measurements, so 9, 12, and whatever the other length is. But what it does is gives me at least a general picture of what I need to do. So again, I would highly encourage people to draw, encourage you to draw a picture. It doesn't have to be perfectly accurate, but at least it gives me a visual reference for what I'm doing here. Okay, so let's just plug some of these numbers in. So 9, let's do 9 on this side. That looks to be fit there. I was thinking 12 for this side. It's a little bit longer. Let's try that again. 12 for this side is a little longer. And then we don't know what C is. So C is our hypotenuse, C squared. We'll just leave it as C. We don't know what that is, so question mark. Okay, and again, the hypotenuse is always across from that 9-degree angle. All right, so now we just plug it into the formula. And this one is a little nicer on us, and you'll see why. So we take our A number, again, formula is A squared plus B squared equals C squared. So my A number is 9, so I'm going to square that number, plus B squared, B is 12, I'm going to square that number, and then equals C squared. So we don't know what C squared is at this point in time. Okay. Okay, so now let's just solve it. So 9 squared, that's 9 times 9 is 81, plus 12 times 12 is 144, and then equals C squared. Again, that's the missing part. That's what we don't know is at this point. Okay, so 81 plus 144, if we add those together, that should give me 225 equals C squared. Now again, if you look at this, your answer is not going to be 225. Again, think about this logically. If I look at C side, if this is 9, right, this A side is 9, this is 12, there's no way this would be 225. So what's the deal? Well, again, we need to undo this squaring that we've done, right? Undo the exponent. So what I'm going to do is I'm going to essentially put the square root symbol or the radical symbol on both of these and just say, hey, let's find the square of both these. So for this, C squared becomes just C. 225, the square root of 225 is 15. So now I have what C equals. So I can kind of erase some of this stuff. So C is equal to 15. And that, again, now let's think about that logically. Does that make sense with the other measurements? Yes, that fits. 9, 12. We know that the right angle side, the hypotenuse side, is the longest length. That's the longest side. And so that does fit. And we can say with confidence that that's our answer. So C is equal to 15. Okay, so again, a very similar question, number one. Number one, we were looking for a missing side, in this case A. In the second question, we were looking for actually the hypotenuse, which is C. Okay, question number three. And in fact, this question is actually questions 3 and 4. 3 and 4 on the quiz. So these are two similar questions. Okay, so which set of numbers could represent the lengths of the sides of a right triangle? Okay, so this is a very typical question. In fact, we've gotten a few questions like this in our in class various times. Now we haven't had a ton of practice with this, but you'll get some practice now. So like always, I'm going to draw a little model. So I'm going to do a 3 by 4, a little longer by 5. Okay, now again, my drawing may or may not be accurate, okay, but it's just a reference for me. So I'm going to make 3 as my A side, 4 as my B side, and I know that, again, the truth about the hypotenuse is that it is always the longest side. So I know that that 5 side is my hypotenuse, or C, right? If I want to write that, that's really my C side. Okay, so here we go. So that's C. So now the question is, does it work? If I put it into the A squared plus B squared equals C squared, write that, does it actually work out? Is 5, in fact, the actual true hypotenuse? So will this be a right triangle? Question mark, right? We don't know at this point. Well, let's put the numbers in and try it out. So A is 3, so 3 squared, plus B, which is 4 squared, is equal to 5 squared. Okay, so in this case, I'm not looking for that missing variable. I'm not looking for A or B or C. I have all the numbers, and I'm simply checking, does the left side match the right side, right? So let's do the numbers. 3 squared, again, like we've been saying, that would be 3 times 3, right? I'll just kind of do a little reminder here of what that expression means. Plus 4 times 4, that is supposed to be equal to 5 times 5, right? So let's do the math. Let's actually do those. So 9, really having a hard time writing my 9s right now. Short legs. Okay, all right, 9 plus 16, and that is supposed to be equal to 5 times 5 is 25. Okay, well, let's check it. 9 plus 16. Well, wow, okay, 9 plus 16 is in fact 25, and 25 is in fact equal to 25. So the equation balances out, is a true equation, and therefore we can say with confidence that this is in fact a right triangle. So it is a 90-degree angle inside there. I can erase that question mark. We know for sure that it is in fact 90, and it is a right triangle. So we could say with confidence that yes, this checks out, right? Check, it is a right triangle. Okay, so let's do it again with one other example. So again, I'm going to draw, I'm just going to draw an example triangle here. Again, my lengths might not be accurate, doesn't really matter. Let's see, so a 5 side, pretty long side over here, 13 side, and then that would be my 15 side. Okay, so so this would be my 5 side, my 13, and my 15. Okay, so again, we're putting into the formula. We're going to see if it works and evaluate if this in fact is a right triangle. So here we go. So A squared, that's my 5 is my A. Again, I'm choosing, we can A and my B sides are interchangeable. let me say question mark, right? We don't know if it's right or triangle or not. So 5 squared plus the b side, which again, that's I'm designating 13 as that side. Again, as long as it's the sides adjacent to the right angle, right? So 5 can be b, 5 can be a, 13 can be b, 13 can be a. It doesn't really matter as long as I am keeping that opposite side, opposite the right triangle, as the c side. So 15 squared is my c. Okay, so let's do the math. So 5 again, 5 squared would be 5 times 5. That's 25. 13 squared would be 13 times 13, and that is 169. And then 15 times 15 is 225. Okay, so now I got to do the math, right? So 25 plus 169, that is going to be 194. And I still have the 225 on the other side. Well, you can see at this point in time that they don't equal each other, right? So that that 225, 194 is not equal to 225. So I'm going to put a slash through the equal sign, meaning those are not equal to each other. So at this point, I know for a fact that this is not going to be a right triangle. Okay, so it's the side lengths are going to cause this angle to be tilted in some way. If I were to draw it maybe more accurately, what might happen is that this 5 side is probably tilted back. So I'll just give a general visual of what this may be exaggerated, but this triangle probably looks something like this. And again, so now again, these are the side lengths, right? So this is my 5 side, here's my 13 side, and this is my 15 side. So notice this is clearly not a right triangle, that corner there. That would be an obtuse triangle. Again, that's kind of a general, maybe a more accurate picture of what this actually is. Okay, so that's an indication. Again, what does this indicate? It indicates that this is not a right triangle. So we'll say X, that is not a right triangle, because the left side does not match the right side, right? So the left side was 194, right side was 225. Okay, so there's two examples, one that works, one that doesn't work. Okay, last question. And honestly, the last question on this quiz is just a reiteration or a reminder. It's going to ask you some true or false statements about the Pythagorean theorem. So here are 3 statements that you can apply to this last question that really give you the information you need to know. Number 1, the Pythagorean theorem states that a squared plus b squared equals c squared. If it's some variation of that doesn't say a squared plus b squared equals c squared, it's not the Pythagorean theorem. Okay, that is it. That is the entirety of the equation. Okay, if it doesn't measure that, or if it doesn't look like that, that's not the equation, right? So Pythagorean theorem is one thing. It is very clear. A squared plus b squared equals c squared. Okay, number 2, this principle only applies to right triangles. We've said that over and over again. In fact, several of these questions have been looking at, okay, is it a right triangle using Pythagorean theorem? So only applies to right triangles. And again, here's this last statement. We can use this theorem to find any missing side of a right triangle. So again, as we saw through some of those questions, so those 3 statements should help you decipher kind of what they're asking you in the various question 5s, because there's a number of different questions that you would get for number 5. Okay, and so thank you for watching this, if you've stuck with me this long. And as always, as in my normal class, since this is in a sense replacing one of my normal classes, if you're watching this, I'm going to end with a joke. So here's our joke of the day. I hope you have, again, if you're watching this prior to spring break, first of all, thank you for being on top of it. And number 2, I'm sure you have a great spring break. Here it is. So I recently went to the world's tiniest wind turbine exhibit. Yeah, it was interesting. Honestly, yeah, just not a big fan. All right, friends. I will see you again soon.